In past lessons, you've worked with quadratic equations in standard form, like this one is shown, and then in the last lesson, you actually worked with quadratic equations in vertex form. What we're going to do today is use the method of completing the square, which we've already done, to convert from standard form to vertex form. The first thing that we need to do is replace the f of x here with the variable y. Then the next step would be to subtract the constant from both sides. Then you're going to factor the right-hand side to make the coefficient on x squared equal to 1. From here, you'll complete the square. In this case, we add 1. Now, on the left-hand side, we know that we need to add 1. The problem is we really didn't add 1 here. We added 1 times 3. So, over on the left-hand side, what you really need to do is you need to add 3 more to that, so that your equation is now y minus 2 is equal to 3 times x minus 1 quantity squared. And now we're in vertex form. Let's list the vertex of this. It's the point 1, 2. Based on this function, you should be able to tell that this is a minimum and the way you can tell is this. You look at A. If A is positive, then the graph is a happy face. And when you have a happy face, you have a minimum. If A is negative, let me erase that, you have a sad face, and your vertex is a maximum. Alright, let's try the next one. Our first step is replace f of x with y. We move our constant over. Factor out the 2. Complete the square. Now again, since we added 9 here, we really added 9 times 2, which is 18. So we have to add 18 to the other side of this equation. That gives us y minus 3. So if we look at the vertex is negative 3, 3. It's a minimum. To find the zeros, we set y equal to 0. I am going to rationalize this denominator. So that gives me plus or minus I times the square root of 6 over 2 I'm going to continue this up here. These are my zeros. They are complex zeros. There are no real zeros. So it's -3 plus or minus the square root of 6/2 I. The domain will be numbers that we're allowed to enter for this, and in this case the domain is all real numbers. The range will start at the minimum and go up. So the range is from +3 to infinity. Or we could write it +3 to infinity. The last one is much more general, but we will go through the exact same steps. And this is the part where we complete the squares. So we cut b over a in half and then square it. So that becomes b squared over 4a squared. Now remember, when you added this, you actually have to add this times a to the other side. So we add b squared over 4a. That gives us y minus c plus b squared over 4a So what I'll do next is I will rewrite this part so that c has a common denominator of 4a. And what that does, because it becomes negative 4ac over 4a plus b squared over 4a. So I'll rewrite the equation y plus b squared minus 4ac over 4a. So now when I write the vertex here is negative b over 2a, and then negative b squared minus 4ac over 4a. The zeros are the ones that we get from the quadratic formula. So I'm going to say negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So what I'm hoping that you'll pay attention to is that this is the x-coordinate of your vertex. You are then going to add this amount to it to get your right hand 0, and then you'll subtract this amount from it to get your left hand 0. The domain is still all real numbers, and the range is kind of hard to say because if a is positive, then the range will be from negative b squared minus 4ac over 4a to infinity. And if a is negative, the range will be from negative infinity up to negative b squared minus 4ac over 4a. Now, the very last thing on your note says the vertex of a quadratic function is. This is a pretty general statement about vertex of quadratic functions. That's the answer. Please write it down.